Hi everyone, a very happy Tuesday and welcome back to our ARM Tech Talk series. This is the place for the latest and greatest trends, technologies and best practices from the ARM ecosystem. So welcome back if you're a regular viewer of the series, and thank you so much for joining us. It's really great to have you joining us today. We had a fantastic week last week at Mobile World Congress. I do hope you're able to join us then. We had an amazing week talking about all the amazing innovations that are built on ARM at the show. We really managed to bring Mobile World Congress to the world from Barcelona live. So if you've missed any of those ARM Tech Talks, don't check them out on the ARM YouTube channel. And they're all there. All 6 of them are there. And we'll be doing more of those in the weeks to come. So do keep an eye out for those. But today we're going to be talking about all about edge AI applications on the new Renesas RA8 series of MCUs. And we're going to be talking all about that with some really great innovations and a really cool demo from the team at Renesas. So we're going to get the team up shortly. I see we've just got Kavita back. Apologies, Kavita. I understand you had some internet connection issues. That's what happens when it's live, but we've got Kavita and Jorhos from the team at Renesas joining us. So let's welcome them. I believe up first we've got Kavita. So let's bring you to the stage. Welcome, Kavita. Thank you so much for joining us for today's ARM Tech Talk.
Thank you very much, Tobias. Very happy to be here, and my apologies for the slight blip.
No problem. This is live, right? This is it's like live TV. These things happen. So, do you mind just going ahead and getting your slides back up? We did have them up, but they've disappeared as you disappeared. So let's get those up. And I know you've got a couple of slides to go through first before we get to Jorhos and the teams and your team's demo. Here we go. We've got those slides up. Perfect. There we go. That's great. I think those actually might just be the old version there, Kavita. Sorry about that.
Yes, sorry about
I just
that.
noticed.
No
problem. Hey, this is live. We're working these things out live for all the practice we do. Let me remove that just for a second and add that one back in. There we go. Perfect. We are live and we are going. So that's enough from me, audience, except to say, when we finish today's presentation and the really great demo from Kavita and Jorhos and the team at Renesas, do get your questions in. This is going to be a really exciting talk with a lot of opportunity for you to ask questions at the end. So do get those in. On the events page, you'll see a little Slido bar where you can enter your questions there. We'll get to those at the end. Right, Kavita, it's over to you. Please take it away for today's ARM Tech Talk.
Thank you, Tobias. And good morning, good afternoon, good evening, everyone. My name is Kavita Char, and I am part of the Embedded Processor Product Management and Marketing team at Renesas. And I'm very happy to be here today to discuss some of the new products that we have recently launched to the market. And I'm just going to move to the outline here. I will start off with an introduction to the new Renesas RA8 X1 series MCUs. I will talk a little bit about the features and some of the benefits that these bring to our customers. I will also touch on some target applications as well as hardware and software enablement for these devices. In the second section, my colleague Jorhos will go through a Vision AI demo based on the RA8 D1 MCUs. He will talk about some of the optimizations to the inference engine based on some of the technologies that we are bringing with these new devices. He will also have a live editing demo and then the actual application towards the end. So without further ado, let's talk about these MCUs. So before I dive into the details of the RA8 X1 series MCUs, I just wanted to say a few words about our MCU product portfolio. We have an extensive lineup of microcontrollers based on multiple architectures to meet the diverse needs of our customers. We have 8 and 16-bit MCUs as well as 32-bit MCUs. At the lower end of the performance spectrum, we have the RL78 MCUs, very well known in the industry, strong legacy of ultra-low power consumption and low pin count lineups. And these devices take the operating frequency up to about 32 megahertz. Moving on to the 32-bit MCU portfolio, we have the Renesas RX family, high performance, power efficient, with a very robust set of peripherals, and these devices take the max operating frequency to 240 megahertz. This is based on Renesas' own proprietary RX core. And then, of course, we have our RA devices, which are based on the ARM M-class cores. Very high performance, highly integrated devices, advanced security, as well as a very rich ARM ecosystem are hallmarks of the RA family. And these devices take the max operating frequency up to 480 megahertz with our recently launched RA8 devices. All of these devices are general purpose devices, which means that they find application across broad markets and like sensors, wireless products, motor control, graphics, and so on. This slide here introduces or tells you a little bit about the Renesas 32-bit RA family. These MCUs are high performance, highly integrated devices based on the Arm Cortex-M4, M23, M33, and now with the RA8 series, the M85 cores. We have devices that span the performance spectrum. We have the ultra-low power RA2 devices, very suited for battery-powered applications with strong capacitive touch and analog features. The midline is covered very well by the RA4 and RA6 devices that have high peripheral integration as well as high performance. And then, of course, we have the newest RA8 series devices that take the performance up a level to 480 megahertz. All of the devices integrate large flash and SRAM on the RA8 series up to 2 megabyte of flash. Security is one of the key value propositions of the RA family, and we have tried to do more in terms of our offerings with every new device that we bring to market. So we have Renesas leading edge security IP as well as options with Trust Zone where the core supports it. And then, of course, we have broad connectivity peripherals, USB, CAN FT, Ethernet, and so on, support for graphics and HMI, as well as a robust CapTouch interface. All these devices are highly scalable from 16 pin to 224 pins and 48 megahertz to 480 megahertz. And of course, transitioning within the family is very easy with the feature and pin compatibility. All the devices are supported by the flexible software package, which provides all of the infrastructure software components that you need to start your application development, as well as achieve the certifications that you need for your end product. So we are very happy to introduce the newest members of the RA family, the high-performance RA8 series. These are the industry's first MCUs based on the new Arm Cortex-M85 core. I list out some of the benefits that these new devices bring to our customers. First and foremost, of course, the highest performance. The Arm Cortex-M85 core is by far the most powerful M-class core in the industry, and it provides DSP and AI/ML capabilities with a whopping 6.39 core marks per megahertz demonstrated performance. So this is a goodish, 15 to 20% sort of improvement in the core mark over other cores of a similar performance. We combine this very high performance core with advanced security for a secure element-like functionality. We build in a hardware-based root of trust and a secure boot process, as well as advanced cryptography with leading-edge security algorithms. And of course, Trust Zone. With the Cortex-M85, ARM has introduced Trust Zone to this high-performance category, of course. So we use, we have solutions that allow for system partitioning and isolation using Trust Zone. While performance is obviously very important for some of these compute-intensive applications, we recognize that lower power consumption is an equally, big key concern for our customers, and we have built in multiple low-power modes as well as features, and a wide operating voltage range of 1.68 to 3.6 volts on these devices. These devices are highly integrated, and we build in embedded flash that will help our customers to lower their BOM costs, eliminate the need for an external memory in the system, as well as simplify their designs with the integration with best-in-class peripherals, as well as graphics. And of course, last but not the least, comprehensive software and tools. So as I mentioned, the flexible software package comes with RTOS and provides you all of the infrastructure software that you need to start your application development. This is a quick look at the RA8 X1 hardware. We have introduced 3 product groups to the market: the RA8 M1, which is our mainstream lineup of MCUs, the RA8 D1, that's our graphics line, and the RA8 T1, which is more optimized for motor control applications. So these are all highly integrated MCUs. The core runs at 480 megahertz. We build in 2 megabytes of dual bank flash, 1 megabyte of SRAM, and 12 kilobytes of data flash. This could help you eliminate an additional E-square in your design. Advanced security, I touched on that. We build in immutable storage, trust zone, as well as tamper protection. Broad range of connectivity options. We have a secure interface to external memory with the Octal SPI interface. We build in graphics IP into these devices with both parallel and MIPI interfaces, several timers and analog features. The operating temperature range goes from minus 40 degrees to 125 degrees junction temperature. Operating voltage range, as I mentioned, 1.68 to 3.6 volts. We have packages from 100 pin to 224 pins, and we have full enablement with software and EKs for each of these MCU groups. I will touch on some of these key features in the next few slides, and I want to start, of course, with the industry-leading performance that we get with the Cortex-M85 core and Helium. ARM recently introduced this new core to the market, and the RA8 series are the first MCUs that brought this core to the market, delivering a 6.39 core marks per megahertz. As a comparison, the Cortex M7 core, it's a 15 to 20% uplift over the Cortex M7 core. These cores are based on the latest ARM v8.1M architecture that bring a couple of new technologies. One of them is Helium for acceleration of DSP and AI/ML tasks, and provides a 4x boost for these kinds of tasks, the DSP and AI/ML implementations. Basically, Helium introduces wide vector registers, which have a SIMD instruction set that allows users to load multiple data elements into these wide vector registers and provide that performance boost. In addition, the new core provides 30% higher scalar performance over the Cortex M7 core. In addition to Helium, the new technology that ARM has introduced to this high performance category, of course, is Trust Zone. I think a lot of you are probably familiar with Trust Zone, available on all cores, ARM v8.0 version and so on, and forward from there. They have also introduced a new technology called PAC-BTI, pointer authentication and branch target identification, that allows protection from software programming attacks. So with all of this functionality and this performance boost, the new RA8 MCUs bridge that gap between MCUs and MPUs and enable those compute-intensive tasks with the ease of use of an MCU and the lower power consumption. So this is a quick comparison of the Cortex M7 core. And as you can see, floating point support, scalar, dual precision and single precision on the Cortex M7 core. ARM has introduced half precision on the Cortex M85 core, both for scalar as well as vector operations. And in terms of just the raw performance, max per cycle, it doubles the performance. So 2x, 32-bit by 32-bit per cycle, multiply accumulates. And core mark, of course, I talked about that. We have demonstrated this performance boost with the Cortex M85 core recently at Embedded World last year in 2023, where we were able to show this almost 4x the performance boost while using Helium with the Cortex M85 core over the Cortex M7 core. And we were able to achieve a 13.6 FPS AI inference performance over the Cortex M7 core. And, this is very remarkable for an MCU without the AI hardware acceleration. The RA8 series MCUs provide flexible memory options. As I mentioned, we have 2 megabyte dual bank flash and 1 megabyte SRAM, half of which is ECC protected. And we also have the option of an Octal SPI interface, which is XPI compliant and supports execute in place as well as decryption on the fly for a very secure interface to external memory. And these graphics that you see here show some of the ways that these flexible memory options allow our customers to build their applications. Customers have the freedom to use the internal flash accelerated with the caches to get the best performance, or they can run the code through TCM. They could also opt for external memory, where the code is in external flash and can be brought in securely using the decryption on the fly and then executed on the Cortex M85 core. They can also bring in this code from external flash into TCM and operate from the TCM. So there's a lot of flexibility in the ways that you can use all of the configurations that are possible with these devices. And security, I mean, this is a very broad and a very, very large topic, and I've tried to just highlight some of the key values that we are bringing with the RA8 series MCUs. First, of course, the advanced cryptographic engine. We build in the leading edge crypto algorithms on the RA8 series MCUs. This is a fully isolated subsystem within the MCUs with very tight restrictions on access to it. And the access is only through the access management circuit, which has specialized software that controls all access to it. And any illegal access will basically shut this down. The IP basically supports all the accelerators, leading edge accelerators for symmetric as well as asymmetric cryptography and a hash engine. We support a variety of keys, the hardware unique key, as well as a set of keys that can allow you to build that strong root of trust. And then, of course, we support the true random number generator. Key management is one of the key aspects of our security solution. No amount of advanced cryptography is useful if the keys get compromised. So we have built in several sort of services that can help you secure those keys. We have, of course, the hardware unique key that is specific to each MCU. We also have services for key wrapping as well as secure key injection that can help you secure your applications. Trust zone, I will talk about in the next slide. PAC BTI with the pointer authentication, ARM has provided the means to verify the return address from functions. And with the branch target identification, it allows you to identify the target of the functions, the target address, destination address. And this basically allows you to protect from software programming attacks, especially in return and jump oriented type of programs. I talked about the immutable storage on the device. The first stage bootloader sits in immutable storage on the RA8 devices, and that becomes the basis of that chain of trust through the device lifecycle. We do provide a secure boot as well. Tamper protection, we have, of course, the time-stamped tamper detect, as well as side channel attack protection with DPA, SPA, as well as timing attack protection. In addition, we have several other services. We have authenticated debug, as well as secure factory programming that allows our customers to program in a zero trust or a non-secure environment. I talked about the secure interface to external memory, and we of course have device lifecycle services that allow that authenticated and very secure sort of movement from the factory to end of life. And of course, we are planning several certifications for our devices. PSA certified level 3 root of trust is in progress. We are also planning CAFP and SP800, 90A and B NIST certifications. We also plan CSEP certifications. Some quick words on the trust zone implementation on RA devices and some that are specific to the RA8 devices. Trust zone, as you know, is the hardware-enforced separation of all MCU resources. This was introduced with the V8M architecture, and it enables the creation of protected or trusted environment. The capabilities and resources can be split into two regions, secure and non-secure, and the secure services can be called by the non-secure code, but through a non-secure callable gateway, which is shown in the second graphic here. The API veneer, the non-secure applications can access some of these APIs from the secure zone, but only through these veneers. And the user has full flexibility on defining their services to be accessible or not through these API veneers. ARM had defined trust zone as applied to flash and RAM, to code and data, but Renesas has taken that and sort of extended that to other buses, pins, and peripherals. So we have trust zone filters applied to our DMA and DTC and other bus masters. This basically prevents non-secure code from extracting secure code through these mechanisms. It also prevents eavesdropping on inputs or overriding the outputs. Also protects all of our external interfaces. Switching gears to HMI solutions, the RA8 D1 is our graphics MCU, and our graphics solution basically has hardware, software, and ecosystem components to it. On the MCU side, we support a graphics LCD controller with the parallel RGB as well as MIPI-DSI interfaces. This is a two-lane MIPI-DSI interface. We have a 2D drawing engine to offload the CPU. We have 8 and 16-bit camera interface, and of course, large memory on chip. The 2 megabyte flash as well as the 1 megabyte SRAM allows customers to have low resolution displays or support low resolution displays without any external memory. For the resolutions that require the large memory spaces for storage of their frame buffers, we have included a 32-bit SDRAM interface to this external memory. The RA8 D1 EK, which is our evaluation kit, the graphics kit, features an LCD panel and a camera module within the kit, which gives you that comprehensive sort of out-of-box experience in developing your graphics applications. The flexible software package has full support for graphics. We natively support the Seger EMWin as well as Microsoft GUIX graphics libraries. In addition, of course, we have a whole set of graphics peripheral drivers and support for some reference code for app nodes and so on for graphics applications. We have a rich partner network with some of our partners in the graphics space. We have native support, as I mentioned, for EMWin and GUIX. In addition, we have strong partnerships with LVGL, Qt, Embedded Wizard, and Crank. All of these partners have recently made announcements of their graphics solutions based on the RA8 D1. So we've talked a lot about high performance and these compute-intensive tasks and so on. But one of the key concerns for IoT applications is also low power consumption. The Renesas basically achieves some of these lower power consumption with a combination of aggressive design techniques as well as technology enablement. We have built in a lot of features on the RA8 series devices that can allow you the flexibilities to get the best power profile for your use case. So if you look at a typical IoT application, the devices are usually in sleep mode and wake up occasionally to either read a sensor or communicate some data over the network, and then go back into standby and sleep modes. So the RA8 series devices have built-in low power standby and sleep modes, as well as CPU sleep modes and low speed modes that can help you sort of configure your system for the power profile that you desire. In addition, we have built in many features like multiple power domains that can be independently controlled, clock gating for all of our peripherals, frequency scaling, and state retention for selected IP. This basically allows for that faster wake up from the sleep modes. We have independent peripheral operation while the CPU is disabled, as well as wake-up signals for the data acquisition and transmission type of peripherals. We have introduced a second VCC domain, the VCC2 domain, which allows our customers to attach 1.8 volt components to the device while the rest of the chip is, or the rest of the pins are running at 3.3 volts. So this gives you that flexibility and also allows you to lower your power consumption. You have options to use either the internal DC-DC converter or external power supply options. And of course, I talked about the operating voltage range, 1.68 to 3.6 volts. This slide is talking about some of the target applications. As I mentioned, the RA8 series devices are general purpose MCUs, and they are suited for a broad base of applications. We have customers using these devices in industrial applications, in smart metering, consumer products, medical devices, as well as smart home and building automation type of devices. And we have built in, obviously, the features that will support this sort of wide range of applications. And this could mean the higher performance of the core. It could mean helium that can help accelerate your AI implementations. It could mean the graphics features that can help you build those graphics applications. And of course, temperature range, higher temperature range for those industrial applications. So we have very carefully sort of curated and built in these features that can help enable these kinds of applications. And I just wanted to take a few moments to share an example of an application using the RA8 M1 MCU. This is basically a fingerprint scanner, and I find this very interesting because it makes very optimal use of all of the resources available on the RA8 devices. The fingerprint, is acquired through either a camera or an SPI interface, depending on the type of sensor. And there is some processing required for this fingerprint to extract the minutiae of the fingerprint, which then needs to be encrypted and sent over to the remote server for processing or for validation and authentication. In addition, an AI implementation has also been added that can make use of helium. And the particular application here is a live fingerprint detection. This is basically an anti-spoof measure. So it uses the higher performance of the Cortex-M85 core accelerated with helium to accelerate the neural network in this application. So it basically makes very good use of all the resources that are available on the devices. Some quick words on the flexible software package. As I mentioned, it's very easy to use, highly integrated, high quality software that gives you all of the infrastructure pieces, including the HAL drivers, middleware stacks that come with the Azure RTOS or the free RTOS, and all of the security APIs that you need to build those truly secure IoT applications and also achieve your certifications. The two, Azure RTOS as well as free RTOS, are native to FSP. They have been fully integrated with FSP. In addition, we allow you the flexibility to bring in any RTOS of your choice. So a lot of flexibility here for you to bring in your legacy code as well as your RTOS of choice and use all of the infrastructure that we provide. This is a quick look at the development environment. We have a very robust set of tools and software that our customers can use. On-chip debuggers, we have our own Renesas E2 and E2 Lite, but we also fully support our partners, Seger, IAR, and Kyle with their debuggers and probes. IDEs, we have our own E2 Studio based on Eclipse, but we also support the Kyle MDK and the IAR embedded workbench. In terms of compilers, we support all of the standard compilers, and I just wanted to add here that for the RA8 series, we work very closely with our partners for enabling the Cortex-M85 core and especially the helium acceleration. So all of our partners now have acceleration with helium. The ARM compiler v6 as well as the ARM LLVM have full support for helium, both helium intrinsics as well as auto-vectorization support, and as do the GCC as well as IAR compilers. We have, of course, a whole slew of support tools, programmers, intelligent pin mapping, FSP driver selection, so several GUI tools to make your sort of development much easier. We also have trust zone configurators, which can help you to configure your trust zone into non-secure and secure zones. Kits and boards, I will talk about in the next slide. So the RA8 series has separate kits for each MCU group that we have brought to the market. So we have evaluation kits for the RA8 M1 and the D1, and a motor control kit, an MCK, for the RA8 T1. All these kits allow access to all of the functions and pins of the device and special features to aid application development for specific applications. Lots of connectivity options, Ethernet, USB, serial interfaces. We also have external memory on the board. Should you need to use that external flash or SDRAM memory, debug capability. The RA8 D1 EKs enable graphics applications. So as I mentioned, it includes in the box an LCD panel and a camera module. And then we have, of course, our specialized motor control kit that comes with the inverter board as well as a motor that you can use to start your development. All of the documentation and collateral for these kits, hardware and software, are available on our website. So just as a quick recap, Renesas has recently launched the industry-first 32-bit MCUs based on the Arm Cortex-M85 core. These are highly integrated MCUs and bridge that gap between MCUs and MPUs. They enable our customers to extend their investment in MCU-based solution and not have to switch to an MPU when they need that sort of additional performance. And this also helps you to simplify your designs and build a sort of wide range of applications. Significant step up in performance. with the Cortex M85 core. Based on the 8.1M architecture, we have demonstrated a 6.39 core marks per megahertz performance with these devices. I've talked about Helium for AI, ML, and DSP type tasks, 30% scalar performance uplift over the Cortex M7. And of course, Trust Zone and PAC BTI for security. And then comprehensive solution with a flexible software package and an entire sort of suite of development tools and kits. So for more product information, please visit our website, renesas.com/RA8x1, and this could be RA8 M1, D1, or T1. And that's all I have on the devices themselves. I will now turn it over to Jorhos to run us through the Vision AI demo. Over to you, Jorhos.
Thank you. Thank you so much, Kavita. It's impressive to see all this information and the capability of the system, and I'm very happy that I'm one of the first that have worked on system level with this device as part of my role and the group that I'm working on embedded processing business division inside Renesas. So moving on my slides, I'm going to start talking about seamless tiny ML development and deployment of artificial intelligence of the things. Why seamless development? Because we have managed to build up platforms, development platforms that allows to go from an idea of a neural network model down to the deployment and experiencing the inference, but as well as on systems that are on the AIoT size, meaning that they are not connected in the cloud, and the processing does not rely on additional capabilities that can be offered from another system, and that makes it more like kind of decentralized intelligence just run on the device. And looking about what are the benefits of this of embedding intelligence to the endpoint is definitely that we have several IoT applications that live with constrained environments, limited memory, limited compute, battery operated, and maybe not always connected. And that's very important because they require real-time response, and that can be on mission or even life critical, expecting device to operate in a non-cloud centric intelligence, and that works in that way with limited or minimum latency, enabling optimized processing for this kind of applications. Of course, and since data are not transformed and transposed over the network, the security concerns related to the transfer and flow of the data are minimized. We don't transfer data, we improve data privacy and security. Last but not least, network agility, because the data are operated at the source, they're really close to the source, exactly to the point that gets generated, and that is reducing power consumption and leverage data gravity, because there's no need to have facilities for transferring data over the network. The way that over this area on MCU and MPU centric AI ML on the edge, like the tiny ML, we have key technologies and endpoints that are using that are using end applications that show on the right, and AI ML that can be classified broadly into three pillars, as you can see here. Namely, these are voice and real-time analytics and vision, of course, and that overall can solve or enhance aspects of IoT systems related to maintenance, effectiveness, reliability, personalization, service safety, security, and other than that. Moving further is the application example and the solution that we have decided to show in this tech talk is about a driver monitoring system, really a system that can be used for controlling or detecting what is the condition of the driver standing in front of the wheel while driving, and that happens just with the RA8 D1. Is a single core MCU based on Cortex M85. So we have done this solution together with our partner Nota.AI, and together we have ported the solution into the system. What in fact the system is doing, it can detect droners, distraction, driver, identify the driver, use of the cell phone or smoking detection. And overall, this is an in-country safety solution powered by AI and ML technology to enhance road safety and all aspects of vehicle travel. Uh, to mention here that although we're doing an automotive-like task, it's the device is certified for automotive, and just we want to show that the processing and the flows and development environment that we built in Renesas allows to use a demanding task like this one, and that's a great achievement that we have done together with Nota.AI. So the key features of the solution is high performance on low-cost edge devices, is interoperable with various camera types, it's flexible installation on positions, and robustness in different environments. The way that the system looks and the way that we have developed is mainly using the FSP and the E2 Studio, our development environment. So everything is designed inside the environment that we offer in Renesas, and the system level in terms of drawing and requirements is shown like that by also showing how the flow of the signal goes over. It starts with a camera that you see on the mid left that drives through the ECU. ECU means capture engine unit, that is a capture module that fetch data, image data from the input, from the external input, and transfer it to the memory. It can capture images on different resolutions, including UBC, including JPEG, RGB, and others, and also can do a bit of format conversion on different points. Then what we have is the drawing engine and the graphics subsystem, which allows to have the graphics controller, of course, driving the LCD in 8, 16, 18, 24 bits of RGB LCD interface. And the very important part is the 2D drawing engine for raster and vector graphics. That engine provides flexible function that can support almost any object geometry, and allows to create bounding boxes, triangles, lines in order to create and help the final application working on like that. It's quite important to mention that there is direct communication between the AI inference engine and the 2D drawing engine, because especially for the application that we're talking about, the driver monitoring system, we are using 3 different models that are cascaded over them with different input requirements, and all these inputs are addressed by the drone engine to help the system work efficiently on this demanding task. The way that in fact it looks is shown here. So we have the camera on the left again. There is a cropping around the place where the face is. That is the model that is driven to the model that detects the face. Once this is known and the coefficients of the face are known inside the full display, then the landmark model runs, which detects again the condition of the face, and on that is also the information of the eye that is extracted by cropping just around the eye, which means that although we're running 3 models, those that you see on the bottom, doesn't mean that each of them is using the same input data, and that makes sense, in fact, in order for to optimize the system exactly in order to allow use the optimal resources out of it. The way that we work on in terms of different options available for writing helium code enable and make all this optimization, it is that each of Cortex-M processor has its own implementation details, and the pipeline stages, and everything has to be supported, including libraries with Helium, like SimSys DSP, SimSys NN, and benefits also of using auto vectorization, which the programmer in quotes can leave everything to the compiler. Although, yeah, I mean that might not be true, and there will be areas that the code needs to be optimized and help the compiler understand where auto vectorization has to be applied, and obviously that improves the operation of the code for this part. It's and resolves any drawback of the approach if the compiler does not do what is wanted for whatever reason, and in that case gives a full control into the system overall. And additionally, using helium intrinsics obviously assist in the same area, and allows to optimize the code by using the instructions, and as well for experienced programmers, assembly modules can be applied accordingly. Looking a bit further and really going to the actual demo right now, I'm going to bring up the environment of the environment that we're designing. I have made the video to make sure that everything runs smoothly, but in fact here is where we see overall the project structure, and the folder contains pre and post processing codes, and overall the deployment is working like this. You can see that the different components of the system, like the graphics display, is being set accordingly to the resolution needed for the operation, and once we generate the setup, everything gets into the system. The right components get generated, which will accordingly allow to have the next step. These are conversion of the quantized models in TF Lite, and they are used for distribution from TF micro source code, like the model CPP and the model HPP, which allows also to have and understand what are different requirements as inputs inside the CEU in terms of creating the model. The three models are shown right here, and each of them have its own files. These files are quantized accordingly with the system that happens right here. So the models, the actual model files are generated, which are less in requirements for processing, exactly because of the quantization that happens. And you can see that all of them get generated for each of the three models that we're discussing. We're creating the operation, then we compile the program. In fact, what we see here is that we see here that on the left side we have the model with helium, on the right side the model without helium, and then that is running accordingly to the device. Here is where you can see that the system moves on and works accordingly, and we can see also the inference, the way it runs. Left side is the helium-enabled case. You can see that the inference time is much smaller than the right side, which is the non-helium case. And in fact, that is coming like this. And what I'm going to show very very quickly as well in this part is the work that moving on creating the models, and how those models gets quantized and helps to improve over the operation that can be found under Nepresso. Nepresso is the platform from Nota.AI, which is a very powerful tool, and this is the way that works to show that it works smoothly within the operation of Renesas development environment. It is an example here, by the way. It's not using the actual models, but this is the system to train a model and also benchmark. It creates an export to the ONCS file required for that. And once training is being tested, there's a benchmarking and optimization using the compressor that's available inside in the Nepresso application. Quickly moving out of this this heavy coded file just to the end, and I want to show you here how the operation is working and what is offered by the compressor inside the Nota.AI Nepresso Studio. In terms of flops, there's improvement of this size with a compressed size, but that also brings an improvement in the memory requirement because the parameters are less that are used, and accordingly, of course, the model size is less than that. And with that, moving back to the slides, where we can really see the operation and the how that works in terms of benchmarking. First, to say that the clock speed is 480 MHz in all the experiments here, and this is the inference speed, the way it looks for the three models that have been used in driver monitoring system with and without helium. The smaller value is the better, and you can see the improvement. But in addition to that, we have experiments with helium and the cache memory enabled, the way that is set up inside the system, inside the RA8 D1, where you see that while just helium can do up to 2.2 improvement, when we combine that with and without the memories that are close to the processor, the improvement is reaching almost 8 times faster in this case. Having said that, the size of the model overall is about 300 kilobytes, which is about the 1/3 of the available SRAM in the system. While in terms of frames per second, it's can reach the 10 frames per second within 100 milliseconds. But for the demonstration, which is going to follow, actually, we have limited that to 5 frames per second, exactly because of the camera that is used. And we have to use this camera because this is the camera that is really inside the box and can be used by anyone that want to try and experiment with this demo. Let me then do the following, and Tobias, I will most probably need your help here because what I want to do is to switch to my other camera. Yeah, thank you so much for that. Stopping the camera for a moment. I need to disable the virtual background and change the camera to the one that okay, I think we're okay. Let me start the camera again. Right, great, amazing, good. Okay, I think that there's some light somewhere. Which light is doing that? Was not that light was not there before. Okay, good. I found it. Yep, likely. You see myself here. My face gets detected. My eye gets detected. There are some drawing into that. If I'm just looking on the camera, everything looks to be getting well. If I look on the screen, the distraction goes high. If I look down, drawness will start, or if I just close my eyes, drawness starts getting. That works with glasses or without glasses, and of course it also works with sunglasses. Right. So that's the demo overall. That's the way it works. This is the overall experience that you're going to have with this demo that we have created together with Nota.AI, and this is the way that you can see the demo and replicate it at your site by getting one of our AK boards. And with that, I have finished I have finished my talk, Tobias. Let me switch back to the other camera. and we're ready for questions.
Absolutely. Thank you for that that great demo and great presentation. You know, it's fantastic to see your use of the Cortex M85, the helium technology in that platform, and we've got some really, you know, and some really exciting tools and opportunities for people to actually go out and use it now, which is great. So I'd love to. There's a couple of questions that are coming. We've just got about just over 8 minutes or so left. One around is actually on that topic of helium, right? And Kavita, maybe you can take this one on your side. Is if I'm, you know, looking to use, you know, I'm a developer, I'm a customer out there looking to use and enable helium on the Cortex M85 core to accelerate that AI, that ML application. What is your advice for how to do that? How to best do that?
So it's actually really rather simple, and I think Jorhos also covered it a little bit in his presentation. ARM has provided SimSysNN and DSP libraries that are fully ready for helium, and they have now been integrated with our FSP software in the latest revision, or the revisions that were released at the time of our launches of the RA8 devices. So as long as you link the SimSysNN and SimSysDSP libraries into your project, you should have support for all of the helium intrinsics. In addition, you need to use helium-enabled compilers. So as I had mentioned in our tools section, I have worked with all of our partners to enable this support for the Cortex M85 and helium. So as long as you use one of those compilers, you should be able to see that acceleration. And this will basically provide you the auto-vectorization support for helium. So both helium intrinsics and auto-vectorization with a combination of the SimSysNN and SimSysDSP libraries being linked into your project and using the appropriate compiler. That should basically open up all of the helium instructions for your use.
Thank you, Kavita. That's great. Yeah, there's definitely some great resources and much more out there on helium on both websites, Arm and Renesas. So do check out all the resources that are available from Arm and Renesas on that topic from that. So do engage with both of us on that. If you've got any questions, just reach out to any of us. And Jorhos, on your side, you know, we've talked about there's some great partners out there that we work with, that you guys work with. You know, Plumerai have featured a demo with you guys a while back. They were one that came to mind, as well as Nota.AI. But also there's Reality AI that Renesas recently acquired. Reality AI. Is Reality AI's toolkit integrated into these development tools that you've got in Renesas?
Yeah, I suspect that the reason that you're making this question is because you have noticed the menu on the development environment on each studio.
It looks familiar.
It's already included in there and supported by the most recent releases of E2 Studio. Indeed, we have integrated everything, and the solution is up and running. It's a fantastic tool that works smoothly. And as you said, after the acquisition, this is a Renesas solution. So we're very happy that we have them together with all the great partnerships that we're working on.
Brilliant, thank you. And I think there's a few questions that come in around kind of on the same theme, which is around kind of availability, right, of this. So where can we obtain the development kit, and do you have a virtual model available for boardless development? Two questions are coming around that same topic. So Kavita, do you want to take that one?
Yeah, so we have a full lineup of RA8 MCUs samples, as well as silicon samples, as well as evaluation kits that are now available through all of our distribution partners. These are all the typical ones that you would see: DigiKey, Mouser, Future, Avnet, and so on. Also, they are available through the local distributors in various regions. So please do check out our website where you'll see the full list of partners and all of the components that they now support.
Brilliant, thank you for that. And virtual, and on the virtual model side for any boardless development.
So Jorhos, would you like to take that? Do we have this virtual model?
We're offering the model. We're offering the board as it is, and it can be ordered from our webpage, as you said.
Yeah.
And yeah, absolutely. And there's also, of course, from the ARM perspective as well, we do have fast models of the Cortex M85 core as well. So if you want to try that out, but that's very much on the fast model side. If you're looking for actual boards, then definitely reach out to to the folks at Renesas and talk to them about that. And the link was the one you shared earlier, right, with all the different endpoints. So we'll get that pasted in the chat very shortly on the webpage very shortly. And actually, someone else has asked about a link to that Jupyter notebook you shared, just on your side. Do we have a link to that we can share as well?
Of course, yes. Everything will come up. Of course, all this is not like public or open to everyone. But in terms of whoever is interested on developing together with Nota.AI, this is the kind of environment that can be used and taken over for creating and importing a model, optimizing that with the facilities that have been developed with our partner, and then, of course, moving on in the combined area of developing the solution.
Brilliant. Thank you for that. And then we've got a couple of other questions coming. One is around, do you support, whoops, I've just lost it. There we are. Do you support Zephyr?
So yeah, I can take that. So yes, we do support, some versions of Zephyr. For a full support, this is ongoing right now. Our software team is actually working with them closely to get this ported over to the RA devices, actually all RA family devices. So this is in progress right now.
Brilliant. And on a similar thread of what things are supported, is Rust programming supported?
As far as I know, not at this point.
No, thank you for that. And then we've had a question that someone plans to use batteries with AI, battery chips with AI to automate energy storage, networking, and collaboration in EVs and consumer products. Would an RA solution support such a use case?
For battery-powered applications, I think it depends on the use case. As I'd mentioned when I was talking about low power consumption, if the use case is such that the product is in sleep mode for a long period of time, just occasionally wakes up to perform various functions, those kinds of devices could potentially use the RA8 devices. We do have a full lineup of other devices, the RA4, RA6, and the RA2 devices that are also very suited for ultra-low power applications, the battery-powered wearables, and so on and so forth. So depending on the use case, I think we have power calculators and so on that one can use to sort of figure out if the power profile matches with their use case. But yes, depending on the use case, it could be possible.
Amazing. Thank you for that. And final couple of questions are coming. What ARM debug IP are available on the Renesas device, e.g. ITM?
Yes, so all of those are available with the ARM Cortex-M85 core. So all of those are available to you.
And final question, what compiler, linker, debugger versions support all of the advanced security features of the RA8 chip, the RA8 CPU chip?
They should be available with all of them. So the ones that I had listed in the development environment, which was all of the compilers, the GCC, IAR, and of course the ARM compilers are fully equipped for Cortex-M85 core. And all of the security.
Amazing. And all the security, yeah. Mm-hmm. Fantastic. Thank you for that. Those are some really great questions. And we are just about at the top of the hour. We've had a great demo, fantastic technical depth. What more could you wish for? So from either of you, do you have any final words to wrap up for today's audience? Before we do wrap up, do you have any final words for today's audience?
Well, I can go first. I just wanted to thank everyone and the audience for your time and for giving us this opportunity to share some of the new things that we've been working on. And if you have any questions, please reach out to us and reach out to any of our regional offices, and they'll be able to provide you a lot of information. Please visit our website as well, and you'll find a lot of information on the products as well as all of the tools and kits and so on. And to you, Tobias, and to the ARM team, I just wanted to say thank you for providing us this platform to talk about our new devices. And we are deeply appreciative, and we look forward to working with you again.
Yep. Also from my side, many thanks to everyone attending, and also to ARM, and also to our partner Nota.AI for supporting us and making this solution. Is work in the background happens before we launch the product. The first product in the market worldwide that is using CM85 and it was a great opportunity for me to work over that, becoming a pioneer on this system and creating solutions around it. And the main focus here I want to highlight is that we're working in a seamless development environment that improves time to market and make those complicated tasks work as smooth as possible for creating great products. So, yep, thanks again to Arm, thanks again to Nota.AI, and of course, many thanks to Renesas for creating and supporting all this nice journey that we have been over the past months.
Thank you both so much, and thank you, audience, for your great questions again. And that about wraps up today's Arm Tech Talk. Join us in a couple of weeks' time for our next Arm Tech Talk. We've got some really exciting topics coming up, focused on our latest and greatest announcements and our latest and greatest innovations from our partners. So do stay tuned. Head to arm.com/tech talk and make sure you're subscribed as well to the Arm YouTube channel so you don't miss any of those. So thank you so much, Renesas. Thank you so much, audience, for joining. And we look forward to seeing you again in a few weeks' time for another of Arm Tech Talks for all of the latest trends, technologies, and best practices from our Arm ecosystem. Thanks so much, everyone.
Thank you very much.
Bye.